Hi, welcome to your next set of video notes. We are going to learn how to perform operations with complex numbers. You might say, what's a complex number and why do I even need it? That's what I'm going to show you today. This looks similar to things we did the other day. We are trying to take square roots and solve quadratic equations that way. Notice there's no b term still, so we're good with that. So we go along and you say, okay, so you subtract 10 on each side. Yeah, Mrs. Roth, we know how to do this. Why are you making a big deal out of it? It's x squared equals negative 16. And I say, great. And then how do we get the x by itself? Oh, yes, we remind ourselves we're going to take the square root of each side. And when you do that, you pull out your trusty calculator and you type in square root of negative 16 and it gives you a problem. Because there is no number that when you multiply itself gives you a negative, right? Because if you go negative times negative, that gives you a positive. And this is when all the mathematicians go, oh, we'll never be able to do this. Wait! Let's just make something up. So they did. They made up the number I, which stands for imaginary number. These are numbers that we have imagined, okay? And what we say is that I equals the square root of negative 1. So anytime you see a negative 1, you go, psh, or a negative, I should say. You just think of it as I, all right? The other thing I want to point out to you is I squared then equals negative 1, and you can plug this in as well, okay? And how cool is that, that you just made up a number? How fun. Anyhow, and if you go back to the picture that goes along with the iTunes U course, you'll see I on there. And so now, if you can explain the joke to me, that's extra credit, by the way. Yes, I did just say extra credit. Okay, so this is a totally brand new idea. So we need to talk about a complex number. And what that is going to be, and you'll see it usually written like this, either a plus bi or a minus bi. We say that a is the real part, and the bi is the imaginary part. And so you might have 3i or 7i or negative 2i, whatever, but it's the imaginary part. Well, you have to figure out how to work with complex numbers. So that's what we're going to do next. We're going to come over here and we're going to learn how do you add complex numbers together. Well, the thing I want you to remember is like terms. It's just like you've been doing all along. Looking at these, what do you think are the like terms? Oh, the real parts. And what is 12 plus a negative 8? It's 4. These kind of look the same because they both have an I. Now you might have said 20 minutes ago you would have called that a variable, but now we know it stands for that imaginary number. So negative 11 plus 3i is negative 8i. How easy is that? Let's go to the next one. What is the like term with the 9? I hope you're all saying negative 6. So 9 plus a negative 6, that's 3. Is there anything kind of like this negative I? Oh yes, a 7i. So let's see, negative 1 plus 7 is 6i. And you're done. How cool is that? Okay, so that's adding. Let's move on, and we're going to look at subtracting. Subtracting, I'm going to remind you, is also like terms. The other thing I'm going to remind you, subtraction messes us up sometimes because we need to watch our signs. Okay, be very careful with this. So, same thing. What is 15? Kind of a like term to is 24. So you say 15 minus 24. Well, that is negative 9. Okay? What's the like term for negative 9? Oh, another negative 9. And let's see. Let's do this off to the side. Negative 9i minus a negative 9i. Ooh, that's like adding, isn't it? So, oh, guess what? Negative 9 is your answer and you're done. You could, if you wanted to, write it as this, but you don't have to. Okay? All right, let's go on down here. Like terms, what's kind of like the 3? Oh yeah, just the real part, the plain number. 3 minus 8 is negative 5. And then you've got 7i. And what is it alike? Or, common terms. The negative 2, so we say 7 minus a negative, well, that's just positive 9i. Now, if you went, I'm really bad at sign numbers. You could still do this on your calculator, do 7 minus a negative 2. Okay, just work with the coefficients. The other thing is, on your graphing calculators, if you go to mode, there is real or imaginary. You could put it on imaginary mode, and then you could type this in. And we'll look at that in class, because I know you hate looking at the calculator on the videos. Okay? Good so far? All right, let's move on to multiply. The words I'm going to give you for multiply are either to distribute, or it's the F word. I would never say that. I meant FOIL. What are you laughing about? Okay, so these are your 2 options. Now, this one does get a little bit trickier. If you're going to distribute, like in this example, negative 5i times 8. Well, negative 5 times 8, that's negative 40i. Okay? Negative 5i times negative 9. Now, do your signs. Negative times negative is a positive. 5 times 9 is 45, and I times I is I squared. But if you think way back, what did we say I squared was the same as? Oh yeah, negative 1. So this is really 45 times negative 1. Now what is 45 times negative 1? Oh, negative 45, and that's the real part. And the one thing is, in complex numbers, the real part has to come first. So you would really need to rewrite this as negative 45 minus 40i. So go ahead, do your multiplying. Plug in for the I squared if you need to. And then make sure you write the real part and then the I. Okay? Let's look at one that's a little bit more involved, because notice we have 2 binomials, so this is when we're going to FOIL. So your first terms, negative 8 times 4 is negative 32. Your outer terms, negative 8 times negative 7i is positive 56i. Inner terms, 2i times 4 is going to give you 8i. And then last terms, 2 times a negative 7 is negative 14. I times I is I squared. Okay, now there's some simplifying we can do. I would go ahead and combine the i's, because they're like terms, so 56 plus 8 is 64i. And I would plug in a negative 1 here. Anytime you see I squared, you know it's the same thing as negative 1. What is negative 14 times negative 1? Oh, that's positive 14. Now, do we have any like terms here? Oops. Don't ever drop your I, it's a big problem. Negative 32 and 14 are like terms, so you get negative 18 plus 64i, and you're done. Okay? And we will practice this, because I know that got kind of involved. All right. Now, we've practiced adding complex numbers, subtracting complex numbers, multiplying. The next thing we're going to do is divide complex numbers. And just like we said before, you don't really want an imaginary number on the bottom. Remember, with radicals, you couldn't leave a radical on the bottom. You can't leave an imaginary number on the bottom. So, this is going to be a reminder that you are going to multiply by the conjugate, or in other words, opposite of the denominator. Okay? So, in this case, the complex conjugate, instead of 1 plus I, we do 1 minus I. It's just going to be whatever there with the opposite sign. Now, here's the thing. You get to practice your multiplying, because we've got 5 times 1 minus I. We also have 1 plus I times 1 minus I. Okay? So let's try it. You get 5, and you get negative 5i. Well, that's not so bad. Ugh, we're going to have to do this bottom, aren't we? And when you've got 2 binomials like that, What's the F word that we use? Of course, it's FOIL. So 1 times 1 is 1. Outer ones are negative I. Inner ones are I. And last one is negative I squared. Okay, so now we just need to simplify. I'm going to come over here. We still have that 5 minus 5i. Those are gone, right? Opposite sides and signs, and that's what's supposed to happen. So you've got 1. And what can you put in for I squared? Oh yeah, that's right, negative 1. What is 1 minus negative 1? Oh, it's 2. And you just get 5 minus 5 halves. And remember, we want the real stuff first, and we want the imaginary stuff second. And you're done, okay? Let's look at a little more involved problem. If we've got this complex number divided by this one, you can't have an I on the bottom. So you have to get rid of the complex conjugate. And let's see, leave those two things there. But what does change? Oh yeah, do the opposite sign. And we know what you multiply on the bottom, you have to do to the top. And now we get to do a whole bunch of FOILing, okay? I think I'm going to just write over here 5 plus 2i, and right next to it 3 plus 2i. We're going to all have that 3 minus 2i and 3 plus 2i, okay? So first terms, you get 15. Outer terms, you get 10i. Please don't lose your i, that would be terrible. 2i and 3, that gives you 6i. And your last one is plus 4i squared. Now let's hold off on that, okay? Let's go ahead and do the bottom. First terms, 3 times 3 gives you 9. Outer terms, 3 times 2i gives you 6i. Inner terms, you get negative 6i. Oh, and they're going to cancel out, yay. And then you get negative 4i squared, okay? Well, let's plug in negative 1 for our i's. Get 15 plus 10i plus 6i plus 4 times negative 1. And on the bottom, and if you notice that, oh yeah, those are going to cancel out. I won't make you write them twice. Negative 4 times negative 1. Okay? I think we could get one more row. So what is 4 times negative 1? Oh, that's like having negative 4. And we can combine those. And what is negative 4 times negative 1? Oh, that's like adding 4. Okay, anything we've got left to do here? Combine like terms, and we've got 11 plus 16i all over 13. Okay? And, I'm sorry, I'm jumping around. We're going to go ahead and write the final answer. Write the real part first, and then the imaginary part second. And that is your answer. Okay? Just two last quick things to do. We're going to look at how to graph an imaginary number. And that's not really too bad, because look at how I labeled the axis. Real and imaginary. So if I wanted to graph negative 3, negative 4i, I'd go over on negative 3 on the real, and my imaginary is negative 4, so I have to go down 4, and it's that point. And that point represents the number. We have to compare real and imaginary. We can't just do x, y. Okay? We could also do a point like 2 plus 5i. So which part's the real part? Oh yeah, 2. So to the right 2. And then is this the imaginary? Do I go up 4 or down? Up? Wonderful. 1, 2, 3, 4, 5. So that's that. Okay?